Welcome to your second lesson training. Today, we'll familiarize you with the cockpit of the K-50 Black Shark. The cockpit consists of several instrument panels that house gauges and indicators that display information on current flight parameters, aircraft systems, status, engine states, flight controls, and system warning indicators. The primary flight controls are the cyclic control stick, the collective control stick, and the rudder pedals. The collective control stick controls the collective pitch of all the rotors simultaneously and equally, thereby increasing or decreasing the amount of lift generated by the rotor disc. The cyclic control stick controls the swash plates, which alters the pitch of the rotors individually as they move around the rotor mast. This creates propulsion and determines the direction of the helicopter's movement. The actual pitch of any single rotor blade at any given moment is the summation of collective and cyclic pitch. The rudder pedals are used to control the helicopter's direction in the horizontal axis, yaw. The primary flight instruments are located on the forward panel beneath the anti-glare shield. The Attitude Director Indicator, ADI, also referred to as artificial horizon, indicates the helicopter's orientation relative to the horizon. It also shows deviation from the assigned flight path in the horizontal and vertical axes. The Horizontal Situation Indicator, HSI, indicates the helicopter's heading, navigation data, and the helicopter's position in the horizontal space relative to the assigned course line or navigation points. These can include waypoints, target points, or airfields. The HSI is helpful in navigating a route or returning to base. The rotor blade pitch indicator is used to monitor the pitch angle of the rotor blades. The barometric altimeter indicates the aircraft's current altitude above sea level, ASL. The altimeter dial has two hands. One full rotation of the long hand represents 1,000 meters, and a full rotation of the shorter hand represents 10,000 meters. The vertical velocity indicator, VVI, measures the aircraft's rate of climb or descent and also is used to help maintain level flight. The rotor RPM indicator displays the tachometer measurement of the rotor's revolutions per minute, RPM, as a percentage of its maximum value. The airspeed indicator displays the aircraft's indicated airspeed. The accelerometer, or G-meter, indicates the current maneuver loading on the helicopter, represented by the white needle. The red needles indicate the highest and lowest G attained during a sortie. The radar altimeter displays the helicopter's altitude above ground level, or AGL, to a maximum altitude of 300 meters. Altitude is measured with a small downward-facing FM radar. The mechanical clock displays the current time in hours, minutes, and seconds. It can be used to measure mission time in hours and minutes, and is a stopwatch to measure short time periods up to an hour in minutes and seconds. The Ecran 32-03 built-in test display is part of the Integrated Cockpit Information System. Ecran functions include diagnostics of all aircraft systems and components that inform the pilot of any failures, and when system tracing mode provides indications of any in-flight equipment operation abnormalities. The Ecran also provides equipment diagnostics using built-in sensors and documents test results during pre-flight checks and ground maintenance. The backup artificial horizon indicates the bank and pitch attitude of the helicopter, side slip, and also provides attitude data to the flight data recorder. The exhaust gas temperature, EGT indicator, displays the exhaust gas temperature for each engine. The tachometer indicates the RPM of each engine turbine. The scale is calibrated to display RPM as a percentage of maximum. The fuel quantity indicator measures the remaining fuel in the front and rear tanks. The display is demarcated from 0 to 800 kilograms. The caution light panels are used to display advisory and caution lights to the pilot. The landing gear control panel is used to raise and lower the landing gear, as well as display the position of the landing gear. The left side of the overhead panel includes the navigation lights brightness switch, the windshield wiper switch, the windshield washer fluid switch, the pitot-static port and AOA side slip sensors heat switches, the pitot-ram air and clock heat switches, the windshield heater setting switch, and the magnetic compass. The right side of the overhead panel includes the rotor de-icing system switch, the engine de-icing dust protector system switch, the left-right pitot heat indicator lamps, the pitot heat test button, and the cockpit ventilation fan switch. The data link control panel is located on the left side of the overhead panel. It is integrated with the weapons control system, and its purpose is to send and receive information to and from other flight members. The L140 laser warning receiver is designed to display the direction and type of incoming laser energy. It indicates 4 horizontal quadrants and 2 vertical hemispheres above and below the helicopter. The UV-26 countermeasures control panel is located to the right of the overhead panel and is used to configure and release infrared flare countermeasures. The magnetic compass is an autonomous, self-contained, direction-indicating instrument that does not require a power source. It serves as a backup to the navigation instruments. The PUI 800 Weapons Status and Control Panel is used to prepare weapons for employment, view weapon inventory and status, and control numerous parameters of weapon delivery. The weapon control panel has the following functions: selected weapon type, master arm switch, storage jettison button, HE, API, and cannon ammunition select switch, short, medium, long burst switch, automatic and manual weapon control system mode switch, weapon readiness indicator, weapon fuel tank presence indicator, selected weapon remaining indicator, cannon rounds remaining indicator, emergency ATGM launch button, arm and disarm switch for emergency, weapon jettison launch, and high and low rate of fire switch. The landing light and voice warning control panel is located in the lower part of the center dash. It controls landing lights, navigation channels, and the automatic voice warning unit, VMU. The panel contains the following functions: main and backup landing light switch, on-off switch for the landing light, inner and outer beacon NDB switch, VMU cease message button, VMU repeat button, an emergency switch for activating voice messages for all warnings in emergency mode. The PVI 800 navigation control panel is used to select the operating mode of the flight navigation system and support its interaction with other systems. The PVT 800 data link mode control panel controls ownership identification and the send-receive modes of the data link. The autopilot panel is used to set flight control augmentation channels and several autopilot functions. The ARC-22 ADF control panel is used to configure the automatic direction finder. The R828 control panel is used to select the channel and control volume and noise reduction of the R828 VHF radio. The signal flares panel is used to control power to the signal flare system and fire the flares. The flares come out in 4 colors: red, green, white, and yellow. A set of 4 flares is located on the left wingtip. The wall panel includes the electrical power control panel that is used to provide electrical power to the aircraft systems. The radio and data link power control panel is used to enable and disable power to the radios, intercom, and data link systems. The fuel boost pump control panel is used to control the fuel boost pumps of both the internal and external fuel tanks. It also provides power to the fuel gauge. The fire extinguisher control panel includes fire warning indicators and system controls. The fuel shutoff valve control panel is used to open and close fuel valves to the engines and APU. The transmission oil pressure temperature gauges. The onboard equipment control panel includes switches for the backup ADI, main hydraulic systems, weapons control systems, strobe beacon, and others. The lighting control panel includes switches for the rotor tip lights, formation lights, cockpit instrumentation lights, and NVG-compatible cockpit lights. The electronic engine governors control panel is used to control the fuel flow at high gas-generated RPM and to shut down an engine in case of power turbine overspeed. The engine power indicator is used to control the engine compressor outlet pressure relative to the red index marker for takeoff B, maximum continuous H, and cruise K. The rear auxiliary panel is located behind the pilot's right side and includes the following controls: de-icing control panel, engine indicators control panel, ejection system built-in test panel, voice message unit bit, ecran warning system bit controls, hydraulic system temperature and pressure indicators, laser warning system and infrared countermeasure system controls, equipment bay lighting switch, and lighting brightness control panel. The left panel includes the R800L1 VHF radio control panel, targeting mode control panel, engine and APU startup controls, radio intercom control panel, and the auxiliary power unit control panel. In conclusion, you should be able to find any of the cockpit controls blindfolded. This concludes the lesson about cockpit instrumentation. You may take over now by pressing the escape key. Have a good flight.